guys, this is Mr. Minnick. Math is my game, and Mr. Minnick's my name. Right triangle trigonometry. Underlining right. We're going to be looking at the trigonometry of a right triangle. That's an acronym. SOHCAHTOA. Or the story about cowboys. Let's learn what SOHCAHTOA stands for. Saddle our horses. Canter away happily. Now you're probably wondering about the TOA. Toward other adventures. Isn't that a nice story? You're probably wondering, what does that have to do with math? Nothing. What is your reference or vantage point? Greek letter theta. He's going to throw that in the triangle there. I think he's up to something. With respect to theta, label each side. Adjacent, hypotenuse, and opposite. Nope. There we go. That's the opposite side. Nope. That's the hypotenuse. And that's the adjacent side to theta. Change some colors here. Now we're going to have to find the opposite hypotenuse and adjacent of blue theta. That's incorrect. The hypotenuse is the right side. On the right. There we go. Adjacent is the side adjacent to it. There we go. And all that leaves is opposite. Trigonometric ratios, or trig ratios. Sine of theta. That's what that'll look like. Going back to SOHCAHTOA, It is opposite over hypotenuse. That's the wrong one. Cosine of theta is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. Yeah, I'm great. That's all our trig functions, or ratios. Not all of them, half of them. They're the most popular ones, the Bob Bistler of the math world. Should we give some quick shout-outs? Shout out to the future Mr. Minnick. Shout out to Nate Emmons for narrating this. A shout out to Mitch Collins because it's his birthday. And that was a joke. And a shout out to Mason. I love you. Right, moving on. The other ones you don't learn about till trig or varsity math. Cosecant. What is cosecant? Cosecant is we're just going to wait till the end to get all these. Secant. Well, cosecant is hypotenuse over adjacent. Oh, my bad. That's secant. Cosecant is hypotenuse over adjacent. Oh, Mr. Minnick, those are the same things. All right, this is getting a little tricky. Cosecant's hypotenuse over adjacent. Nope, that's secant. This guy's just playing with me. Cosecant is hypotenuse over opposite. And last but not least, what's that say? Cotangent. Which is, we'll find out in a second, adjacent over opposite. Those right there are all of our trigonometric ratios. Sine and cosecant are inverse. Or reciprocals. Cosine and secant are as well. Same goes for tangent and cotangent. They're all reciprocals. seems weird to me. This one seems really weird to me. What's going on? I don't get it. You probably think that sine and cosine should go together and secant and cosecant should go together, but they don't! It doesn't mess Taylor up, though. She knew that. What did the grape say when the elephant sat on it? Nothing. It just let out a little whine.
Thank you, Mr. Nate Emmons, for narrating. So hopefully, so far, we're all on the same page. Everybody's got all this stuff written down. We've got right triangle trig. It's real important that we mention the fact that it's right triangle trig. It pertains, these concepts pertain to right triangles. I don't know if anyone's noticed, but the few right triangles that I sketched are missing some things indicative of the fact that they are right triangles, aren't they? What's missing? That little box, the little notch, whatever you want to call it. Right triangle trigonometry, right triangle trigonometry. So the acronym SOHCAHTOA, some people come up with some weird stories. My high school science teacher came up with the story about horses. Sat our horses, canter away happily toward other adventures. However you memorize it, once you understand how that works, these are a piece of cake. The reference angle, theta, it's real important that you understand how to label parts respective to the reference angle. The reference angle is going to be one of the interior angles that's not the right angle. And then we saw sine is the ratio of the opposite to the hypotenuse. Cosine is the adjacent to the hypotenuse. Tangent is opposite to adjacent. And then these three other ones, like I said, they're inverses, or like Nate said, they're inverses. The cosecant is the numeric inverse, or the reciprocal. Notice the sine is opposite over hypotenuse. The cosecant, the sine and the cosecant are each other's reciprocal. The sine is opposite over hypotenuse, so the cosecant is the hypotenuse over the opposite. I don't know if you caught that first time around, and I kind of dropped the ball when I was writing it. It's confusing. I don't know why. The sine starts with an S. Why doesn't its reciprocal start with an S? It should, but it doesn't. The cosine's reciprocal or inverse, and it's not an inverse. It's better to say it's a reciprocal. The cosine is the adjacent over the hypotenuse, so the secant is its inverse. It's the hypotenuse over the adjacent. And the tangent and the cotangent, to me, that makes sense, but the other ones don't. Okay. How's everybody doing so far, all right? Question about the Greek letter. The Greek letter theta is a 0 with a line through it. Some people write it where the line bisects the circle, like it's a diameter. Some people write it slightly above. Some people, when they write the Greek letter theta, they write the Greek letter theta with kind of a circular appearance to it, so it looks as though it's a sphere, and it's like the midpoint or the equator of a sphere, I guess. So. Doesn't really matter how you write it, as long as you know it's theta. Some textbooks will use A, some will use B, some will use X, some will use Y. Just be aware of the fact that it is a variable and it stands for a reference angle. Okay. And when you're talking about the sine and the cosine and the tangent, it doesn't make sense to talk about them without talking about the sine of an angle, the cosine of an angle, the tangent of an angle. Okay. Another question. Are we going to be using beta too? We could put out all the Greek letters if you want to. Alpha, beta, gamma, delta, delta, delta. Can I help you? I don't know many Greek letters. We could use beta. Any other questions before we continue? If not, let's get right to it. Example 1. Find the sine of A, the cosine of A, the tangent of A, the sine of B, the cosine of B, and the tangent of B. We know each one of these is going to be a fraction. It would be nice if we had a right triangle. So let's go ahead and bring in a right triangle. One thing that really troubles me about math and about the way math is taught in schools, and I don't like the word teaching because I really don't think that I don't see myself as a teacher. People say, well, what do you do? I say I'm an educator. There's a big difference. I think I've gone over my philosophy of education. I'm not going to bore you with that. But anyways, the way math is presented, a lot of times people leave things out and it really bothers me. It drives me nuts. Or they make up crap. In my advanced algebra class yesterday, we were talking about logarithms and people make crap up. You got to be careful. I was tutoring a 6th grader one time, and their teacher gave them triangles to solve, and the triangles were impossible triangles. You know how it's like there's certain, like the lengths of the legs have to be a certain sum in a triangle for it to make sense? Right triangles, you have to be really, really careful. If the length of a leg is 3 and the other leg is 4, I can't just make up some random number and say, well, the next one's going to be 11, because that's not a right triangle. So you really got to be careful, and you really got to know your stuff with these. So I'll just start with the basic one, 3, 4, 5. That's a Pythagorean triple if you forgot about those. Not drawn to scale, should be aware of that fact. But that is a true right triangle, a 3, 4, 5 right triangle. So, do we have enough information to answer the 6 questions before us? There's not enough information. It says find the sine of A. Well, what the heck is A? It's a reference angle. Well, what the heck's a reference angle? We don't know what it is because it's not labeled. Does that make sense? So back to this reference angle thing, it's a big deal, it's important. A lot of people overlook the fact that you need to understand a reference angle, what it is, and with respect to that reference angle, what the parts are, the adjacent side, the hypotenuse, and the opposite side. So before I can answer those 6 questions, we need to label this triangle. Most right triangles, not all, but most, label the right angle with a C if they're using A, B, and C. So which one's A and which one's B? Truthfully, it doesn't matter. Sometimes A is the shortest one. If A, or the smallest angle, if A is the smallest angle, it'd be the angle opposite the longest, or the smallest side. So we could say this is A and this is B. Now do we have enough information to find those 6 parts? Now we do. So for a minute, 59, 58, 57, 56. For a minute, I want to focus on A. In other words, I just want to focus on these first 3 questions here. If I'm focused on that, what I need to do is I need to label parts of the triangle respective to angle A. Respective to angle A. Respective to angle A, I need to understand what part of the triangle is what. In other words, I need to know what the ADJ is. I need to know what the HYP is. And I need to know what the OPP is. And some people say, well, that's easy. Well, it might be, but you have to know them, and if you don't, you're not going to be able to do this stuff. So where's the ADJ? Is it this side, or this side? The 4? Why is it the 4? What's the word adjacent mean? It means not opposite. It means I'm standing next to the podium. Next to, I should have said adjacent. And it means next to, but not the hypotenuse. So the ADJ is this one, so where's the hypotenuse? It's the 5. It's the one that's across from the right angle. There we go. So that's a hypotenuse. So then by default, the other side is the OPP. Back in the day, there was a song about that. So anyways, then the sine of A, once you understand this, sine, what do you mean sine? Saddle our horses. Sine is the ratio of the opposite of the opposite of the opposite to the hypotenuse. So what's the ratio then for the sine of A? The sine of A is the opposite, which is what? 3, and the hypotenuse is the 5. What do we think so far? Does it make sense? Everybody doing okay? I don't want to insult your intelligence, but at the same time, I don't want to leave anybody in the dust. Anyone ever gone trail riding on four-wheelers? Trail riding on four-wheelers? I go riding with people all the time, and they say, I ask them before I go, I say, can you ride? And they say, well, yeah, I'm a real good rider. I said, seriously? And they say, yeah. So I have trust issues, so what I do is I go really slow. And about every 600 feet or so, when there's a spot where I know it's safe to look back, I'll slow down and look back to see if they're there, just to make sure I don't leave them in the dust if I'm leading on the trails. So, because you know what happens. They said, oh, no, go ahead, open it up. Go wide open throttle, I'll keep up with you. So you do, and next thing you know, you're waiting for 20 minutes, and they're nowhere in sight. I do that all the time on trails. I'm not bragging about my riding, I'm just saying sometimes it's easy to leave people in the dust sometimes. So I don't want to leave anybody in the dust here, because once you get this, it's a piece of cake, but I don't want to leave anybody in the dust. Does anybody have any questions, comments, concerns before we move on? Yeah, question. You have to memorize the formulas. Well, the acronym is intended to help you memorize it. The saddle our horses, I'm not going to ask that on a trig question, if that's your question. The acronym is I might write the acronym on the board, like SOHCAHTOA, but really that's supposed to help you memorize the stuff. So I guess to answer your question, do you have to memorize those? You should memorize that the sine is the opposite to the hypotenuse, and the cosine is the adjacent to the hypotenuse, and the tangent's the opposite to the adjacent. Yeah, okay. The other three at this stage I'm not super concerned about, but they do come up in the homework, and that's why I mentioned them. Okay. So what about this second part? What about the cosine of A then? What's that going to be? The cosine of A, canter away happily. The adjacent, with respect to A, the adjacent to the hypotenuse. So it's going to be what to what? 4 over 5. Everybody all right so far? Meow. What about the tangent? TOA, T-O-A. The tangent is the 3 over the 4. So one thing that I want you to notice about the sine and the cosine and the tangent is all of those ratios in this particular instance are smaller than 1. Let me say this. When you write a ratio for the sine and the cosine, they will always, 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 without exception, be smaller than 1. Sine and cosine ratios. Sine of any theta, cosine of any theta, will always be smaller than 1. If you have one that's bigger than 1, you did something wrong, or the triangle is labeled wrong. Those ratios are always going to be smaller than 1. 3/5, 4/5, they're smaller than 1, we're okay. It's kind of like a system of checks and balances. Okay. Notice I didn't mention the tangent yet. We'll get to that one. Is everybody okay with what we've done so far? Okay. So now let's go ahead and look at this other one. This time we'll go with respect to B. With respect to B. With respect to B, our sine is the opposite. Well, what's opposite B? What side's opposite B? The side whose length is 4. It's the side AC. So this is the OPP. The HYP will be the HYP no matter what the reference angle is. And so this 3 over here, the side BC is the adjacent side. So what's our ratio then going to be for the sine of B? It's going to be 4/5. And then what's the ratio for the cosine of B? It's going to be 3/5. And what about then for the tangent of B? The tangent of B is going to be 4 what? 4/3. Everybody all right so far? Notice again our sine and our cosine ratios, bless you, our sine and our cosine ratios are again less than 1, right? That's always going to be the case. But our tangent ratio this time is what? It's bigger than 1. Sometimes it's smaller than 1, sometimes it's bigger than 1. Okay? So the tangent ratio can be bigger than 1. Another interesting thing to notice here are these relationships. Notice how the sine of A is the same thing as the cosine of B. And the cosine of A is the same thing as the sine of B. Did anybody catch that? And also notice that the tangents are each other's, the tangent of the one angle compared to the tangent of the other angle are each other's reciprocal. Anybody catch that? So we doing all right? So check this out. Example, I'm drawing with lines here. Example 2. In right triangle ABC, the sine of A is 5/12. The sine of A is 5/12. Find the following. The cosine of A, the tangent of A, the sine of B, the cosine of B, and the tangent of B. Do we have enough information to find all those? Pythagorean theorem? Well, hold on, wait just a minute. Let's go back. Let's be a big fine woman and back that thing up for a minute. We said that the sine of A is the same as the cosine of B, right? Did we not? So we don't even need to sketch anything yet. The sine of A is 5/12. So of those 5 things I'm asked to find, which one can I answer? I know what the sine of A is, so I know the what? The cosine of B. So the cosine of B is going to be 5/12. All right. Good. Now, I know that the sine is the opposite over the hypotenuse. So in anything that has a hypotenuse in it, I should know what the hypotenuse is, right? What's the hypotenuse? The hypotenuse is 12. So in anything, in a cosine or a sine, in anything that involves something with the hypotenuse is going to be 12. So we could do that without even sketching anything without the Pythagorean theorem. Everybody catching what I'm throwing here? So now's the point in time where it might be nice to sketch a right triangle. C, A, B. So we know that the opposite side from A is 5. We know that the hypotenuse is 12. Now this other one then, that's going to be something we're going to have to do a little bit of work on, right? How do we find that? Somebody said the Pythagorean theorem, so it'll be the square root of 12 squared minus 5 squared. So it'll be the square root of 144 minus 25. So it'll be the square root of 119? That sound about right? Square root of 119. So this would be the square root of 119. This would be the square root of 119. So what's the tangent of A going to be? Tangent of A would be 5 over square root of 119, and I'm going to put an asterisk next to that. Technically, we should rationalize that denominator, which we'll talk about a little bit later. And then the tangent of B would be nice, rad 119 over 5. How's everybody doing with this, okay? So far, so good? Comments, concerns, short debates, long debates? Well, one thing that I don't know what books show you and what they don't, but I want to look at something here. The sine of theta over the cosine of theta. if I make some substitutions here, the sine is the opposite over the hypotenuse over the adjacent over the hypotenuse, which means then that's the opposite over the hypotenuse times the hypotenuse over the adjacent, and the hypotenuse is canceled, so it's the opposite over the adjacent. What can I say then about the sine divided by the cosine? What's that really equal to? What's the sine over the cosine really equal to? Thank you, the tangent. That's a trigonometric identity that a lot of times you're asked to prove. Oh, no, proving trig identities. Thanks, Obama. Are there any questions, comments, concerns, short debates, long debates up to this point? If not, there's one more thing from the past that I want to show you, and then we'll go to an example, and then we'll go to Math Excel, and then that'll be that. I have a joke, but it's probably not the best one to tell. It's really not funny. What happened when the butcher accidentally backed into the meat grinder? Got a little behind in his work. That was wrong. That was wrong. Okay. There's some special right triangles. Some special right triangles, this kind. Anybody remember how those work? Two of the sides are equal, so it's an isosceles right triangle. Does anybody remember how much longer the hypotenuse is than the other side? Real quick algebraic derivation of it. X squared plus x squared equals, who knows? What do we want to call that other variable? So I'm just going to call this other thing h. So this equals h squared, so I've got 2x squared equals h squared, so x squared equals h squared over 2. So x is the square root of h squared over 2, so it's the square root of h squared over the square root of 2, so it's h over the square root of 2. I got to multiply by rad 2 over rad 2, so it's h rad 2 over 2. Is that right? Did I do that right? No, because it's supposed to be longer. I solved for x. I was solving for h. Crap, sorry about that. Led you down a rabbit trail. Anyway, the point is that it's rad 2 times as long. It's rad 2 times as long. It's x rad 2. It's rad 2 times as long. The other right triangle that is special is the 30, 60, 90 one. 60, 30. Suppose we have the shortest side as x, the longest side, the hypotenuse is twice that length, and then the other one is rad 3 times x. I don't know how much of that you're going to need to know for the this homework, but those are some special right triangles that come up. From time to time. It's been a long time since I've taught geometry. It's been a whole year. Since I've educated people about geometry, I should say. Is geometry the worst math to educate? Geometry is a very weird facet of math. I don't like where it fits in the whole study of high school math. I don't think it makes sense where it is, and most of my colleagues agree with me. So, question about these two right triangles. The 30, 60, 90, it looks like 50, but this is supposed to say 30 in here. Okay, it looked like it said 50. My handwriting got sloppy there for a second. That's a 30, 60, 90 right triangle. The deal is the hypotenuse is twice the length of the shortest leg, and the longer of the two legs is radical 3 or 1.7, approximately 1.7 times the length of the short leg. Okay, so we'll do one quick example here. Solve for x. Right triangle. Our reference angle is 26 degrees. It's indicated that it's a right triangle. X is this adjacent side, and we know that the hypotenuse length is 17. I like saying 17 like that with a B in it. 17. So here we go. Oh, I don't know what to do. I don't know how to write an equation. Well, whose fault is that? I wonder if we have any tools, if we have any acronyms, if we have any stories about cowboys. Saddle our horses. I wonder if that would help me. With respect to the 26, this x is my ADJ. What that means is the sine isn't going to work because the sine has an opposite in it and it has a hypotenuse in it. It doesn't have an adjacent in it, so the sine's out. The 17 is my HYP. Well, I wonder if toward other adventures, I wonder if that'll work. Well, the tangent relates the opposite to the adjacent. Well, I don't know anything about the opposite side, so the tangent's out. I wonder if the cosine will work. A C and an A and an H. Hey, the A, got that. The H, I got that. That's the one. That's the one. The cosine of the angle. The cosine of the angle equals something over something. X over 17. A lot of people drop the ball when they go to solve these. It's really not that difficult to solve this. All you do is just multiply by 17 on both sides. Real easy. 17 times the cosine of 26. The problem is people don't know how to use their calculators. The problem is people don't know how to solve equations because they don't think. Because I don't know what happens. If you're using a TI-83, you got to be real careful. By default, this calculator likes radians. You have to be in degrees. If you're not in degrees, you're going to get it wrong. 17 cosine 26 gives us 15 point change. If my mode is set up for radians, I'm going to get the wrong answer every time, just about every time. Okay? Make sure your calculator is set up in the appropriate angle measure. Great question. How do you know what to set it as? Usually in triangles, most triangles that we study, when you see the reference angle, suppose it's 46. If you see that little symbol up here, of course, most of us know that means degrees. Usually it's degrees unless otherwise indicated. If it's radians, they'll tell you that the angle measure is in radians. Okay, so good question. Any other questions before we look at Math Excel? Radians is a whole nother story. I could spend the whole class period talking about radians. It's just another angle measurement. It's kind of like the difference between feet and kilometers. You know, it's just a different unit measure. To me, radians makes as much sense as the metric system. In other words, I think it's better than degrees, just because it provides an easier way of counting, I think. So real quick, I'll log into Math Excel. While I'm going to give a shout out to everyone who had the fortitude to take trigonometry this year. I'm going to give a shout out to all the math educators in the building. I don't want the grade book. Where am I going? I want the grade book. I want the homework. Here we go. I want the homework. Trig homework. Here we go. One of these days that window's going to open. Here it is. Oh! This isn't even about trig. This is just about the Pythagorean theorem, isn't it? Bless you, bless you. They want the length of the missing side, so it's going to be the square root of 16 squared plus 30 squared. Pythagorean theorem. If you don't know how that works, go back to geometry. That was mean. That was low. 34. There we go. Oh my goodness. The sine of theta. The sine of theta. That's sine's what? Opposite? So what's opposite theta? 16. What's the hypotenuse? Well, we just answered it, right? It's 34. Question, do we have to reduce? Well, let's check it like this. It says, nope. Although your answer is equal, it's not in the correct form. Be sure to read any instructions given. Simplify it. So that would go to what, 8/17 then? 8/17. Good. So the cosine then would be 30 over 34, but that's going to reduce to what? 15 over 17, bam, like a boss. So the tangent is the opposite, 16 over 30. That's going to reduce to 8 over 15, bam, like a boss. Cosecant, is that the reciprocal of the cosine or the sine? So I look at my sine and I just flip that over. So it's just 17/8. 17/8. So the secant is the reciprocal of the cosine. So I flip 15/7 over and I get 17/15. Bam. And then for the cotangent, I flip over my tangent. My tangent was 8/15. So I'm going to have 15/8. What do we think? Pretty easy? That one wasn't bad. Okay. Sine of 45. So here's my 45 right angle sine. Opposite, 1 over hypotenuse. Oh crap. Oh crap. This is where life becomes difficult. 1 over the square root of 2 is not in simplest radical form. So this is where we do this trick where we multiply by rad 2 over rad 2, which gives us 1 rad 2 over rad 2 times 2, which is rad 2 over rad 4, which is rad 2 over 2. That's the way they want that one answered. Rad 2 over 2. Rad 2 over 2. How's everybody doing, okay? We got time for a few more. Ooh, the secant of pi over 3. What the heck? What's pi over 3? You have to know what a radian is. Oh my gosh, why do they do that to you right now? Pi radians is 180 degrees. So pi over 3 radians, I guess, would be 180 over 3, which would be how many degrees? 60. So in your notebook, if you haven't written anything down yet, write that. Pi radians is 180 degrees. Pi radians is 180 degrees. Pi radians is 180 degrees. So what they're really talking about then in this problem is a 60-degree angle. The secant, so the secant is the inverse of the, or the reciprocal of the what? Of the cosine, and the cosine is the adjacent. Cosine is adjacent, so adjacent to the 60 is the 1. The hypotenuse of the 60 is the, how come this isn't working? The hypotenuse is the 2, but then I got to flip that over, so my secant of pi over 3 would be 2. There we go. Couple tricks to that one, huh? Let's try another one. Sine of pi over 4. Wait a minute. Pi over 4, 180 over 4 is 45. Okay. So the sine of a 45-degree angle. The sine of a 45-degree angle would be 1 1 over rad 2. And the cosine would be also 1 over rad 2. What happens if you take 1 over rad 2 and you subtract 1 over rad 2? What do you get? Seriously? So you get 0. There we go. All right. This one. And then this will probably be it for today. So this homework, I have a feeling this homework might take some of you a while to complete. This is going to be an epic fail right here. Check this out. I'm going to take a picture of this, cut it out. We're solving for A. Notice that A is not the area. The first time I read this problem, I read it totally wrong. We're solving for A. A is the opposite. I know the adjacent, so I'm going to say the tangent of 39 is A over 440. So A is 440 times the tangent of 39. So I got 440 times the tangent of 39. Make sure I'm in degrees. So I got 440 tangent 39. And I get 356 and change. 356. 356. There we go. How's everybody doing? Yeah, the rounding can be tricky. Watch that. It's been real. It's been fun. I hope everybody has a terrific Thursday. It's Throwback Thursday, so happy day. See you all later. Thank you again, Nate, for narrating.